everybody, and welcome back for lesson 24-2, day 2, where we're going to talk about exponential word problems, specifically any problems involving compound interest. So make sure you have the notes sheet for today's lesson, something to write with, and a calculator or the Desmos log calculator to help you out with solving some problems today. Okay, so the compound interest formula uses this formula here, A equals P times 1 plus R over N raised to the n times t power. Okay. Now, compound interest means you're taking a principal amount of money. So you're investing some amount of money and you're putting it into a bank at some interest rate. Okay. Now, when that interest is compounded, it means it takes the money that you earn from that interest and adds it to the original amount. And then that new account or that new amount of money will start creating more interest. And then after a while, they'll take that interest and add it in. So to compound interest just means to add interest into your previous amount of money, okay, over a certain amount of time. So let's go through this formula really quick before we apply it to some problems, okay? But first, let's start with P is your principal amount invested. So this is your starting money, okay, the money you're going to the bank with and opening the account with. This is your starting amount. R is your interest rate as a decimal. So make sure you always change that percent to a decimal before you even put it in the formula. N is the number of times per year that the interest is compounded. So you're going to use this little chart on the side to help you. Okay, this stuff right here. So, and it says something like compounded semi-annually. That means semi means half. So every half year, okay, you're going to be compounding your interest. So that would be 2 times a year. Quarterly is 4 times a year. Think 4 quarters in a dollar. Monthly, there's 12 months in a year. Weekly and daily, okay? And then T is just going to be your time, okay? So this example I stole from the book. It says Wesley has a gift from his grandfather of $3,000. He's going to deposit in a 4% interest rate. So you see how that 4%, they changed to a decimal, 0.04. Okay, we always change decimals to percents to decimals by moving the decimal place 2 places to the left. Okay. Okay, how much money will he have after 3 years? So that's the T. There's your 3. It says the interest was compounded quarterly. Quarterly means 4 times a year. So that's where these 4s are coming from. So all you do is put this in a calculator and make it simplify the answer for you. But after 3 years, Wesley will have $3,380.48. So if Wesley puts his $3,000 in the bank and doesn't touch it at all, after 3 years, he'll accumulate an extra $380. Okay, so let's do some examples together. Let's look at this investment. We're going to take $3,500 and put it in a bank account that has a 4% annual interest rate. Calculate the cost you will have in 5 years if you compound it quarterly, monthly, or semi-annually. So we're going to do this same problem just 3 different times. Okay, so our investment is the P in the formula. So we're going to take $3,500. That's our principal, our starting amount. Okay, my rate is that 4% as a decimal, so 0.04. The amount of money we'll have in 5 years, that's your T. Okay, so let's plug that into our formula. Now, if we're compounding this problem quarterly, that means 4 times a year. So your N here will be 4. So I'm going to take my formula. We have 3,500. 3,500 times 1 plus our rate divided by N raised to the N times T power. Okay. Now the rest we're just going to leave up to our calculator to do the work for us. We're going to work smarter, not harder. So let's see. We're going to take 3,500. I'm going to times it by 1 plus. Now, if your calculator has this option, I would do it. I'm going to hit alpha, y equals, enter, and it'll give me this fraction, 0.04 divided by 4, raised to the 4 times 5 power. I'm just going to multiply that and just put in 20. So that way I don't have to worry about doing any extra order of operations. But if I punch that in the calculator, that's what I get. Now, if you're using an older calculator or Google, you're going to have to put in some extra parentheses here. So I'll show you really quick how to type it in. So it'd be 1 plus that fraction. You're going to have to put an extra set of parentheses. So 0.04 divided by 4. Okay. And then close the first set of parentheses, and then raise to the 20th power. So we get the same answer. So if you don't have the option in your calculator to make that little fraction bar, you can do it in your calculator just the same, just put parentheses around that fraction. Okay, but if we invest our money at 4% compounded quarterly for 5 years, we'll end up having $4,270. Now, if for money, we always round to 2 decimal places. So we're going to have 0.67 here. So 4,270 and 67 cents. So there's our answer. Okay, so we did nothing with our money besides invest it, and after 5 years, we've gained, some money there. Now let's look what happens when we compound our interest monthly. Now monthly means we're doing it 12 times a year, because every month will compound, so that's 12 times, 12 months in a year. So I'm going to cheat a little bit. I'm just going to recopy this over, so I don't have to rewrite it out. So we're using the same principal rate. The only thing we have to change here is the n, because we're not doing it 4 times a year anymore. We're doing it 12 times. So I'm going to change those 4s to 12s. Okay, and then put this in my calculator. Got my 1. Put my fraction in, 0.04. Now I'm dividing by 12. Okay, raised to the 12 times 5 power. Well, 12 times 5 is 60. So instead of putting that in the calculator, I'm just going to multiply it out. Okay, so our answers are pretty close, but we do get a little bit more money if we compound monthly, $4,273.49. So I have $4,049. Okay. All right, one last one. Let's see what happens when we are compounding our money semi-annually. So semi-annually means 2 times a year. Every half year, we'll compound our interest. So every 6 months. That happens twice a year. Okay, so again, I'm going to cheat. I'm going to use the same formula. Okay, and just change my n's out. So the n for this one was change the 4s to 2s, because we're compounding semi-annually now. Okay. And let's see. That's fine. Let's type this in. Too big. 3,500. 1 plus our rate, so 0.04. Now we're dividing by 2. Raised to the 5 times 2 power would be to the 10th power. So that's how much money we'd have. $4,266.48. So I forgot 48 cents. Okay. So you can see the more times a year your interest is compounded, the more money you're going to make. So like monthly, in this case, is the best deal out of the 3. So if you went to a bank and they asked you, gave you some options, you could always calculate your interest and see what you would make. Okay. So I'm going to have you guys try one. I'll move the formula down for you so you can see it on my screen. Okay, but you have $24,100. It's compounded quarterly. So quarterly is telling you your n. So quarterly means how many times a year. At 14%, so make sure you change that to a decimal for your rate. How much money will you have after 5 years? So there's your time, your t. And remember, the money you originally invested, that's your principal. So go ahead and plug that into your formula, okay, and see what you get. Okay, if you did everything right, this is the answer that I got. So $47,953.91. So here's my work here. So we're starting with $24,100. 0.14 is our rate. 5 years. Quarterly means 4 times a year. So I plugged it into my formula, put that in my calculator, and spit out my answer for me. All right, the last thing we just have to talk about now are the problems on the back, where we have interest that is compounded continuously. Okay, so if it's compounded continuously, we can't use an n, because continuously would be an infinite amount of times. So we can't really say n equals infinity. So instead, we're using a new formula. We're going to call this the PERT formula. If you look at it, it's the amount we'll get is equal to our principal, so our starting amount, times e to the r times t power. So that's how I got PERT. Okay. So you can look at this example in the book with Wesley. Okay, again, it's the same amount of money with the same rate. He's just seeing how much money would he have if he compounded it continuously. So again, we're just going to use our calculator to evaluate these, but let's do a couple problems together. Okay. So again, our formula we're going to use is the amount we're going to get is our principal times e to the RT power. So our principal here is $2,000. That's the amount of money we're starting with. We put it in a bank account that has a 5% interest rate. So 5% as a decimal would be 0.05. You always move the decimal 2 places to the left. Okay, compounded continuously should be your Q that you're using this formula. Okay. How much will we have after 5 years? So there's our T. So let's put it into the formula. We have 2,000 times E to the R, so 0.05, times 5 power. Okay, so watch me put this in our calculator. If you forgot where the E was, you're going to need that for this problem. So it was 2,000. The E is above the division sign. So if you hit second division, you should get the E. Raised to the 0.05 times 5 power. Now that I can't really do in my head, so I'm going to let the calculator do that. So we'll go ahead and hit enter, and there's our money. After 5 years, we'll have $2,568.05. 5 cents. Okay. So there's our final answer for that one. Okay. So there's not much to this equation. Most of it is just, plugging in your calculator. So I'm going to have you guys try one on your own, and then we'll do example 3 here. So in this one, you're investing $3,500 in a bank at 8% annual interest rate. How much money will you have in 10 years compounded continuously? Okay, so go back to your formula from the top. Okay, this PERT formula. Yeah, I'll just move it down so we can see it. There you go. So your principal times E raised to the R times T power. So see what you get. After 10 years, how much money will you have in the bank? Okay, here's the answer I got. So $7,789.39. So my work, here's everything set up. My principal is $3,500. My rate, 8% is 0.08. T is 10 years. So if I put it in my calculator, that's what I got. Okay. And make sure your answers make sense. They should be increasing. If you're putting your money in the bank, you shouldn't end up with less money after 10 years than you started with. Okay, so if you ever get an answer that doesn't really make sense, just double check how you typed in your calculator. All right, we're just going to do one last question. This one's a little different, so let's go through it. We have, how long would it take an investment of $7,000 to earn $3,000 in interest if it's invested in a savings account that pays 4.19% annual interest compounded continuously? So for anytime we see continuously, we have to know that we're using the PERT formula. Okay. So our principal is the amount of money we're starting with. So in this problem, our P is an investment of $7,000. Okay. They want to know how long will it take. So in this problem, we're going to be solving for T. So we'll get to that in a second. But they're saying, how long will it take a $7,000 investment to earn $3,000? So in the end, what's the total amount of money we're going to have? If we have $7,000, We want to earn $3,000 in interest. What's that total going to be? Well, 7 plus 3, we would want our total to be $10,000. So in the end, we want the A value, the amount of money we get out of it, to be 10 grand. Now our rate is 0.0419. Turn that percent to a decimal. Okay, and the T in this problem is what we're solving for. We know how much money we're going to have at the end, but how long will it take to get $10,000? So let's just set up everything we know into our formula. So we have $10,000 equal to $7,000 times e to the 0.0419 t power. So this is an exponential equation because the thing we're solving for, t, is in the exponent spot. So we're going to have to do a little log equation to figure that out. But just like when we did equations in the previous video, we need to get our exponential by itself first. Okay, so I need to get this e part by itself. So to do that, we're going to divide out this 7,000. So let's get our calculators. 10,000 divided by 7,000. So we get let's just round 1.43. 1.43 is equal to E times 0 raised to the 0.419 t power. Okay, so in the previous lesson, we learned how to get rid of the E, or how to undo an E function, and that's by using a log. Now log base E is the same thing as our natural log. So we're going to rewrite this as a natural log. So this would be the natural log of 1.43 equal to our power. So 0.0419 times t. Okay. Now the rest of this we're just going to do in the calculator. So I'm going to open my calculator, hit the natural log button. So the natural log of 1.43. So we get this decimal, 0.357. Equal to 0.0419 t. So now the last thing we have to do to solve for t is just divide out that coefficient. So I know this problem doesn't really have nice numbers, so that makes it a little harder. That's okay. So in my calculator, I'm just going to hit divide. 0.0. I forgot the number. 0419. Okay, so we have 8.5. So that means it's going to take 8.5 years, okay, for our $7,000 investment to turn into $10,000. Okay. Now, if you don't have a calculator that can do LNs, you can still use our log-based calculator that I made for you guys. Okay, you would have to do the natural log of 1.43. So you have to use the LN calculator. Type in the 1.43, so you get that decimal, just like I did, okay, on my problem. 0.357, and then divide out that coefficient for t. So again, it wasn't a nice problem because of all the decimals and not nice answers, but we could still accomplish it. Just you have to use a lot of calculator work. Okay, so your 2 word problems, or your 2 formulas, don't let the word problems confuse you. All you're doing is just mostly plug and chug. The only time you have to do a little extra work is if they're asking you how long, and you have to solve for a t. But other than that, you're just doing normal, okay, plug and chug using the formula and substituting the values correctly.